All right, it's 9 o'clock. It's time to get started. Last people swooping in. Okay, great, welcome. It's super nice to be here for the first installment of the Swetugg conference here in Gothenburg. I've been to the Stockholm one many times, but it's really nice to come down here and meet all of you. My name is Jakob Ehn. I work for a company up in Stockholm called Active Solution. We're helping our customers to build great software, mainly on the Azure platform. And I'm a developer at heart. I've been coding since I was, 10 years. I still do a lot of coding, but these days it's also a lot of like architecture, DevOps stuff, rising above the common people, let them do the things as effectively as they can. And I'll just try to spread my experience and knowledge the best I can. So this topic, I'm a consultant, and I'll let this strip sink in because it resonates very well with me and also with I think many of you. Because as a consultant, it's very, very common. I mean, not just as a consultant, basically when you start a new project, you will end up there and you try to be effective, you try to commit code, do some fun stuff early on, but it's really, really hard because things will never work as you expect. The program, the source code will, if you manage to actually authenticate and log in and get the code, it will never compile the first time, right? And it will take usually at least 1 day or probably 2 or 3 days to get everything up and running. And it's really frustrating, and you can't really explain at the end what did you do to the people who decides and show you the money. So it's okay, you won't understand it anyway, right? So this is really happens all the time. So I would say this is a very common problem in software development, and I work a lot with the DevOps practices, where we talk a lot about what happens after you commit to your code. So we talk about things like build automation and deployment, testing, all those things. But before you even commit code, this is also a very common problem and a frustrating one, like setting up your developer workstation and actually be productive. So these are a few of those common problems. After those 2 or 3 days, when you actually get that project up and running, you kind of end up in this it works on my machine problem, because along that road, usually you did some tweaks, you changed some config files, you copied some code, and eventually it ran. But you can't really explain, what exactly did I do? Sometimes you have these README files. You've probably seen those, developer README files, and they are great, at least initially, because then they're kind of accurate. But then, 1 month later, it's not accurate anymore because things change all the time. So it's really hard to keep those things updated. Also, the hardware specification seems to be, the requirement on our machine seems to be increasing all the time. This is another problem, keeping track with the systems being more and more complex. I've yet to see a developer say oh, my machine is super fast, everything flows so nicely. That never happens. So that's another issue, being effective, have a good hardware, and be effective, being able to commit a code on day one on a new project. That's really the goal here. So when I talk about the development environment, what is part of that? Well, obviously it's your IDE, if it's VS Code or Visual Studio or whatever you have. Then of course it's the code. You need to get the code from somewhere. But then there's all the other things, right? Those are the obvious ones. You need your code and you need your IDE. But then you have things like the tools that you need to have installed. Often you need the different kinds of extensions to actually be able to work effectively with the type of project that you're working on. If it's database related stuff, if it's web extensions, other types of extensions. Then you need to get your dependencies to be able to compile the project. So you need to have everything set up to actually get your dependencies from NuGet or whatever they are. There the debugger setup, and also your personal and team settings, keeping the IDE the way you want it. So things like color schemes, syntax highlighting, those kind of things is also something that you want to have on all your projects. Some of those are team settings, and some of them are personal to me. But all this together is maybe what we could call like a development environment, and this is what we want to have set up as easy as possible. So the goal here now is to we talk a lot about infrastructure as code. You probably heard that, and there will be sessions on that today. But we can also think about your development environment as code. That's the goal here, to actually, instead of using a README file or a Word document and build your environment, it would be really nice if you could just keep this in code instead. Tuck it into source control, together with the application. So once you open that source base, your environment should just be up and running the way you want it. That's the goal here. So we put everything in source control. So in addition to the code, like the tools, which extensions do I want, what setup scripts should run, all that things. And now it's versioned, so it will flow along with the code, which is really nice. And people can contribute to this environment setup. So this is a team environment thing. So as long as we go along the way, we will add, for example, new extensions, new setup scripts, and those kind of things. And this is much better than compared to having this in a document file, because that will inevitably be outdated. And again, the end goal here, allow the developers to quickly be productive, right? That's what we want. And optionally now, it would be super nice if we have this now, if we can describe our development environment as code, so we can automate the setup. Wouldn't it be really nice then if we could actually run somebody else's development workstation, at least when we wanted it, to maybe get some more powerful machine when we need it. So now this is now like a real possibility once we've gotten this far. So let's talk about GitHub Codespaces. How many here have used it? None. How many here are using GitHub at all? That's a few of you. And for the rest of you, don't worry, you will eventually. There's a lot of push going towards GitHub. But I want to say that a lot of the things I will talk about is actually not strictly related to GitHub. You will be able to use this to get a lot of the benefits actually by running, for example, on your own machine with this environment setup that I will show you. But then you can use CodeSpace for this thing where you can actually run it in the cloud. But GitHub Codespaces, blazing fast cloud developer environments. So VS Code backed by high-performance virtual machines that starts in seconds. That's like the tagline. So you can see the connection there to VS Code, as you will see. So a lot of these things actually builds on top of Visual Studio Code and the extensibility that is already in that environment. So these are our managed environments that are hosted by GitHub in the cloud somewhere, and you'll just rent them. And you can access this from anywhere on the browser or from your VS Code on your local machine if you want to. And it's customizable then, and this is really the main idea. It's not just a virtual machine with everything on it. You can customize it really any way you want. So you'll be able to configure it to contain the things you need for that particular project as well. So you'll not just have one type of code space. You have many types of code spaces, each one that will fit to that particular project. And you can select them from a list of machine sizes to basically the more you pay, the faster it will be. And again, this will be up to the type of project you're building. For some cases, it's fine to have a really low-end computer. And in some cases, maybe you want to scale up to use a more powerful one, at least for a while. But that will cost you then basically more money. So you're paying for the CPU, the usage, as long as you're using it. In addition to that, you'll pay for the storage, even if it's on or off. But of course, that's a lot lower. And this is available if you have the GitHub team or enterprise. And you can also get part of the preview for use for a personal use as well. So, as I mentioned, then GitHub Codespaces, it's kind of works around this main tooling here, where you have your code editor on the left. It could be VS Code in the browser or on your desktop. And then you'll have a server somewhere, and on that server there will be a container, a Docker container. You won't see it. Inside that container, that's actually where everything happens now. That's where you will working on your code. So your code will be cloned into that one. When you're building the project, it will build on that container, and you can run your code on that container. So this container now is practically your development environment. You access it from from a browser or from VS Code, and then it's hosted somewhere in Azure. But again, you don't really know where. You can select which region it will run in. So, but the thing I kind of circle in here, this is actually part of. This is not part of GitHub Codespaces. This is part of VS Code really, and a part called the Visual Studio Code Remote Development. So this has been around for a couple of years. It's basically a set of extensions to Visual Studio Code that lets you use VS Code somewhere else. It could be on your computer inside a container. It could also be on a remote computer, because VS Code is already built in that way that it's basically a server part and a client part, and that server part can really run anywhere. So they open up for this possibility to actually run VS Code, the server part, somewhere else on a remote machine that could be more powerful, or inside the container, which will give you a lot of benefits that I will talk about. Has anybody used this? A few of you. So this is really what kind of forms the basis that will give you a lot of these benefits that I talk about around keeping your development environment as code. So this is available even if you don't have to use GitHub. This has nothing to do with GitHub, but GitHub Codespaces has built on top of this. So again, this works like this, that you have your local machine where you run VS Code, and then you have a remote OS somewhere which will run the server part, and there you'll have your source code, and that's where you run your application and debug it and so on. And it comes in 3 different flavors. You can use it with the SSH, you can use it with I don't remember what the last one is called, but then you have the container one, which is the most common one, and that's the one that's also used by GitHub Codespaces. So again, it means that you actually put everything in the server part inside the container, and that container is now your development environment. So I'll show you how this works and how you can get a lot of benefits here. So because the reason for using containers now, just to kind of take a step back here, instead of using your local machine, it's like, again, if you take it back to all of the things that you need to install to actually be able to build and debug your application, you need to have that on your local machine. And that's really messy. And then you switch to another project, which maybe requires another set of tools, maybe different versions, maybe they're not even compatible with each other. So containers, like Docker containers, they have solved this problem a long time ago, keeping things isolated from each other. So most people think about containers for running things, maybe in production. You run your software inside a Docker container, but it's a perfect fit for your development environment as well, because again, we need to have this set of tools installed of a particular version, and we don't want it to conflict with other things we have on the computer. So container is a perfect fit here. So I'll show you a demo of how we can try this out, and most of you haven't used it. So I have VS Code, and I already installed the VS Code, the extension for for remote development. So that's why I have this remote explorer here, and this one will just actually let me browse my existing environments. It could be inside the containers, or it could be in a GitHub Codespace somewhere. That's like the explorer part. But once you install this extension, then you get this functionality to be able to work inside a container. So the only thing you need except VS Code and extension is to have Docker installed. If you want to run these containers on your local machine, you need to install Docker. But again, that's it. And again, that's like the promise of Docker. You install Docker, and then you have everything else inside these containers, right? So the easiest way to try out this is to use the samples that come. So you can select this try a development container sample. I hope you can see in the back. Is it okay? So you can select to try one of the ready-made samples. This source code is available over at GitHub. So I'll select .NET Core. And so what happens now is that it will clone this code, and it will spin up a container now behind the scene. And that container again is now my development environment. And if you're interested, of course, you can kind of delve into the logs. We can go back to that, but that's like a lot of detail what happens under the hood. But really, you don't have to care about that, because now we are inside VS Code. We have access to our code. Everything looks pretty much the same. There's nothing like different. You work exactly the way you're used to it. So I guess like the main differences now is first up down on the left here. You can see this little green thing. It says with a little symbol there. This means that VS Code is now connected to a remote environment. In this case, a container with that name. That's the default name just for this sample, dev container C# sample. But of course, I could name that anything. So that's how I know I'm actually connected to something. It will look the same if I'm connected to a GitHub Codespace, as we'll see later on. And the other part is if I'm looking in the terminal now, you can actually see that this terminal now is, I can see I'm in a Linux environment. And if I type commands down here, you can see that this is now actually commands running inside a container. It's not run on my host. So for example, if I take a look at which versions of .NET I have, it says I only have one version. It's even an old one. It's 3.1.422. That's the one that's available now. And let's just compare this one to what I have on my local machine. So we'll list it here as well. And again, this is like on my host. I have a lot of other versions here. I don't even have that particular version, the exact same version that's a container. And again, that's kind of the point here, right? To be able to work with this particular project, I only need one version of .NET, and I need a specific version, right? That's the point here. So that's already installed inside my container here. So that's kind of what's different when I work like this. Otherwise, it's the same. I can compile it. Of course, that's what happens inside the container where I have the tools needed, and we can run it. And when I run it, VS Code is smart to kind of browse the output from your application and try to figure out if we should expose a port or forward a port from that container. So it said, oh, actually, I noted you probably listen to 5000. You wanna browse that one. So it already forwarded that port for me. So we can open it up, and it says "Hello World" in a really small font up here. Again, that happened like automatically, so I'm actually being able to run the application. I can access it through the ports. That was done like automatically for me. So super simple. So and to see where is this thing actually running, we can go back here. I know this dark thing is a little bit hard to see back there, but if I'm just using the Docker tooling to see what's running on my machine now, I can see that there is one container running with a really long name, but it says something around VS Code remote try.NET Core blah blah blah, and it's been running for 3 minutes here. So this is actually now my dev environment, and that was spun up automatically for me when I used this try sample. And this container is running. If I stop it, all the state will still be there. So if I like disconnect and close my machine and start it the next day, everything is still there. And of course, from inside it, I will work with Git as normal, and I will push code as usual. But everything is there, and the only thing I really need on my machine, again, is VS Code and Docker. That's it. I don't even need to install like .NET, the tooling, on my machine, because I don't need it to build it or run it. Okay, so that's just super quick how to get started with the dev containers. But the interesting part now is how do you actually customize this thing, right? We just did a sample, so we didn't really see how that actually worked. So this is done by using some conventional files that will be checked into the repository that you're working on, which makes a lot of sense, of course, to have this together with the rest of your source code. So you will have a file called the dev container.json. So this is the JSON file that specifies how your development environment should look, right? What should be the name of it, what should it contain, which ports do you want to forward, and so on. And the other one is a Docker file, which actually specifies more what's actually installed inside a container. And so an example could look like this. And let's just walk through some of these things. So probably the most important one is where you specify actually the container, what should actually be inside my dev environment. So this could now point to a Docker file that in turn then actually contain the commands to build the environment. It could also point to an existing Docker image. And this is quite common, like if a company starts adopting this, you'll probably build a set of predefined developer images that already contains everything, so you don't have to build these things on your local machine. You just say that if you're working on this project, we will prepare a Docker image for you and we'll push it to our own container registry, and then you will just point to that one. So there's both of those options. So the next part is the extensions. And extensions are, these are things that you typically you're used to just install them on your IDE. And the next time you reinstall the IDE or you switch computer, you have to reinstall them, and sometimes you do, sometimes you don't. And everybody has like their own extensions. And a lot of extensions makes a lot of sense to share, right? Because they give a lot of value. Some of them are like personal. I like this, but you don't. But some of them are actually really useful for team development. And those extensions, it makes a lot of sense to say that we should always be using them for this particular project. And then we'll add this to this dev container file. So we'll add the list of extensions that we should always have when we're working on this project. Then we have things like port mappings. Sometimes you need to be more specific which ports you actually want to expose when you're running the application locally. You can see before they actually picked up this automatically, but sometimes you want to be more specific. And then you have things like these lifecycle commands like post create, post start, pre-start, those kind of things. And again, this is very common to have this kind of setup like hooks, like things that needs to be done when you start working on a project. So like maybe create and see the database or something like that. Run various setup scripts that should always be run. So those are perfect to put in these lifecycle commands. So in this case, it just runs a .NET restore, which is, it's nice. It's not strictly super necessary, but it's an example of what you could do here. So let's take a look at this, what it actually looks like when you do this. So let's close this one. Oops. So I'm going to select the close remote connection. And that now actually will disconnect from that container, and that container will actually be stopped as well, but it will still be there on my machine, so I could start it up later again if I want to. And you can actually see, if I zoom in a bit here, you have this the recent list here, VS Code, and you can see that the first one now, it says dev container at the end. And that means that if I just click this one, open it, it will go straight into that dev container. I don't have to kind of specify that I want to open a container. It will just start automatically. So it's really like just open that project and it's a dev container. You don't really have to even care about it. So that's really nice. So, but I'm going to open just another folder which already has just a .NET new project in it. And so this one is now is a regular project, and so I'll add a dev container file to it. And I'll use this one to says add development container configuration file. And again, it helps me with a little bit of wizardry here, so I can kind of start off with something and then customize it. So it kind of asks me, okay, what are you using here? So you have a lot of different options here, like a set of predefined setups. I'll just select C#.NET. I select the latest version in this case. It asks me, do you use Node? No, I don't. It also asks me now to select additional features here, and I talked about the Docker files. That's where you kind of would add things that you want to have inside your dev environment. And while you can do that, they also took an extra step here to actually make it even easier for you to install common things, and they call this features. So this is just a way for you to make it easier without knowing too much about how you install things in Docker. You can just select some of these things, and this list is like growing. So if you want to have tooling for for Kubernetes, for example, you can just click this one. That will install those tools inside, and you don't have to know how to do that, which is kind of nice. So they call this features. But I'll skip that and add it. And as soon as I did this, VS Code pops up a question down here. It says, hey, this folder contains a dev container configuration file. Do you want to reopen this folder now to develop in the container? And this question will pop up every time you open a folder in VS Code that contains this dev container file. So it will ask you, hey, it seems like this is actually a containerized dev environment. You want to work in there instead? And of course you do, because it's much more fun to work in a container, right? So let's just click this one, reopen in container. And again, now it will happen the same thing as we saw before. It will kind of reopen the same folder, but now everything is inside that container. And we see the same things. We see that now I'm again running in this Linux container. And it's connected to my dev container. But let's take a look at the files then that we actually got. So we got these two files up here. We got the dev container and we got the Docker file. So let's take a look at the dev container to start with. And of course these are like, there's a lot of commented out things here that you will just take away. But and you can see the link over to GitHub where these things are stored and documented. So first up you have the name. We could change this to Swetugg. And then you can see you can have the reference to the Docker file that I talked about before. And then we have some argument for that particular Docker file. So again, here is typically where you would point to your Docker file and you will add stuff to that Docker file, or you would point to an existing Docker image. And then we have the list of extensions they want to have. So, okay, so let's say this is now like a .NET project. So let's add an extension that we think will be valuable for this project. And so, you know, to install extension in VS Code, you would go over here and you would search for, you know, .NET. So let's add something. We could take like let's say we want to focus on tests. So we want to have a nice Test Explorer UI. So just pick an extension here. And so what I could do, I could select install, or actually it says install in dev container here. But I would just install it now in my running container. And it wouldn't really benefit anyone else on my team. If they picked up, they wouldn't have that extension. That would just be installed in my running container. So instead of doing that, I will add this one to my dev container. And to simplify this, because I need to know kind of the internal name, I can actually right-click here and select copy extension ID. And then go back to here and just add this to my list of extension, like that. So that means next time I'll open this one, that extension will be automatically installed, not just for me, for anyone who opens this repository. They will have this extension now. And that makes it a lot easier because it's already there. We can refer to like in setup things or how you work with this project. It's already, you don't have to say that to install it. It's already there. It's really nice. And again, a lot of things. We don't have time to walk through all of these things. Let's add one of the post create commands. We could do this .NET restore just to see how it works. So we say that every time you open this one, you start an environment, I want you to do a .NET restore so that it's already done. So I don't have to do that myself. Okay, but now we have like this catch-22 problem, like we're working inside the development environment that's defined by this file, and now I change this file. So how does that work? How do I apply these changes? Well, you do that by select the rebuild container option here. So I have a lot of commands related to this extension, and I can select the rebuild container, which I'll do then when I did a change here. So now it will close the connection. It will kind of reparse my container file and rebuild it and reopen the dev environment. So this is how you actually work with the environment itself. So it restarted. If we look down here, we should be able to see that it actually ran .NET restore, like when it created. And we should also now see that we have another extension here, which we do. We have this extension, it's already installed there. So we have this Test Explorer extension installed here. Again, if I would close the connection, that extension would be gone. It's not part of my default setup extensions. It's just part of that project now. again, really nice. So to prove that, I'll close it. And you can see that now that extension is gone. Instead, I actually have this the Docker extension, which is like installed on my host. So you can see like the list of extensions actually is updated depending on that dev container environment. All right. So that's how you customize it. It's really simple. Now it's quite common to have like the need. You don't just have your project. Your project is typically dependent on something else, right? So here are some common examples. You have the SQL Server, Redis cache, Cosmos DB emulator, or something. Everything you need, like to be up and running, to be able to, to work and run with your project. And of course, one option would be to actually install these things inside your dev environment, inside the Docker file. And it's possible, but that will actually be a lot of work, and you would end up with a really, really complicated Docker file in the end. So a better option is to use what's called Docker Compose, which is a standard tooling with Docker to actually run multiple containers. And that will let you actually to not just start your dev environment container, but also the things that you're dependent on. So for example, a SQL Server or a Redis cache. So let me just go back and show you how that actually looks. So I'll open a project that is kind of a little bit more realistic than the new world things we've been looking at so far. So I'll open my good old QuizBox project, like a standard demo project, which is a web application. It has a web API, and then it has a SQL database for the storage. And again, when I open this folder, it asks me, this contains a dev container file. You want to reopen it? I do. So I click this one. And it's going to start my dev container. And as you'll see now, it will start not just my dev container, it will also start a SQL Server automatically, because my project needs it. So let's just take a look at how this file looks then. So again, I have my dev container file here. And so if you see up here, instead of pointing to this to Docker file, I actually point to a Docker Compose file. And that's now where all the magic sauce is. And then I just specify with the service which of these services that I define in the Compose file, which of those is actually my dev environment, because that's the one you're supposed to connect to, and that's then the dev one. And the rest of this file looks the same, pretty much. So let's take a look at the Docker Compose file here. And so without talking too much Docker Compose, this is where you specify like the list of services, the list of containers that I want to have up and running. So the first one, that's my dev environment. That's this thing you saw before. So I just pointed to my dev container file, and that's pretty much it, the Docker file. In addition to that, I have my DB service, which now just points to a SQL Server image. So basically what this results in, when I open up this folder, open up my environment, I will have everything running. And I could actually do a run all to see that it also actually works. Of course, it also has like the .NET tooling and everything that I want. I also have some SQL extensions actually over here, because this is a SQL project, so I probably want to have those. So let's see if it is up and running. And it found the port, and yeah, that's my QuizBox application running. And this application, unfortunately, is a little bit shaky in the beginning, but now it works. So I know it works, and it actually communicates with the database. And to kind of show you that, if I go back here and to see what's running now, it's a little bit messy, but it's actually now 2 containers running, where the first one is my dev container again with everything in it, and the other one is my SQL container. So that's how you work with projects that have multiple dependencies like that. It's really, really easy. And it just starts automatically I just open it in VS Code. So I don't even have to explain this to another developer. Just open the project in VS Code and start working, and everything is up and running. Okay. So, GitHub Codespaces. So we looked at all of this. So GitHub Codespaces is that, but kind of made into a service in the cloud. Because now we ran everything on my machine, and you get a lot of benefits by doing that. I just want to say that, like, really try to use this kind of tooling because it will help you a lot for, like, team development. But again, GitHub Codespaces then. So when you're working and running things in the Codespace, it's very, very similar to what I just showed you. It's just that instead of running it in a container in your machine, it runs on a container somewhere else. And you'll build your application, you work with the source code, and you can also like debug and run it. And you saw when I ran the program locally, it actually found the port and did the port forwarding to localhost. It actually works in the same way for GitHub Codespaces, but of course it won't be localhost. But it will actually generate a URL for you, so you can actually also run the application and access it from outside the Codespace. And if you want, you can share that URL to have other people look at your running application, even though it's running in the cloud somewhere. So again, it will forward the port, and you can just access that through the browser, and I'll show you that in a second. So I mentioned this is pay as you go. I'm not sure the prices is actually maybe not the most recent one, but it's still, these are like the different types of machine sizes that you can pick, from 2 cores up to 32 cores, and different types of RAMs, and then you basically pay by the hour. And again, when you stop it, you just pay for the storage, which is like a really small fee. And these environments, they will start up automatically when you access them. If you just close your computer or go to lunch, it will automatically stop after like a pre-configured interval. I think the default is 30 minutes. Then it will stop. And again, nothing will be gone when it stops. It just kind of hydrates. And then when you access it, it will automatically start again. But of course, there is a monetary thing here. You don't just want to keep it running for a long time if you're not using it, right? And you can also specify things like minimum and maximum requirements. Like some projects need a minimum type of machine, because I, as a developer, I select which machine size when I create this code space. But you can make sure that say that you have to have at least 8 GB of memory, otherwise it won't work. But you can also, as an organization, say that you're not allowed to use the most expensive ones, for example. And there's spending limits and those kind of things in place as well, so you don't run out of costs. So let's take a look at GitHub Codespaces then. And so I have another sample project here, just from Microsoft on my GitHub account. And so the default way of working here would be to click on the code one, and you would kind of copy the URL, and you would clone that project locally, and you would start working, right? That's how you would usually do it. But instead, if you enable Codespaces, you have actually another option here, which is the Codespace one. So it says, welcome to cloud editing, which is really cool. So instead then now to, as I said, clone it locally, I will select create Codespace on main here. That will use like default settings. I'll show you can also configure this. So when I do this, now it spins up a machine somewhere in Azure. It will clone the repository. It will look at this setup. If I have a dev container file, if I don't have a dev container file, it will just use a default image, right, with a lot of things installed, which will work for many cases to get you started. But then probably you want to add a dev container file to it. So it builds this one. It connects, and this the time here varies. Sometimes it's really fast. Sometimes it takes maybe 30 seconds. The first time you create it. So we'll see how it will be this time. Come on. So this is the advantage of working in the cloud. Connecting. So it's typically a lot faster than this. Let's try one more time then. Oh, okay, of course. Okay, it's usually a lot faster than that. You have to believe me. But I didn't build this, so I don't know. I don't have to defend this, but usually it's faster. Okay, so now I'm inside like the web-based experience, and you know this is available in GitHub. Like, you know, probably some of you have used the web-based editor. You know, like if you're in a GitHub repository and you just press the dot, it will automatically open up this web-based editor, right? So that one is not like tied to the GitHub Codespace. This is just a way of editing things in an IDE on the web. But if you open this in a Codespace, like now it's actually connected to this Codespace. So you can see down here, I have this little green thing down there, says it's connected to a Codespace. But now I'm able to actually start working on this particular project. So let's, for example, let's run it. So this is a Node application. So like you could do npm start. And it starts, and it says this now it's listening on port 3000. You want to take a look at it. So now you'll see like this is very similar to what we did before locally. But if you take a look at the URL now, it's a little bit different. So you get this GitHub preview.dev domain name, and you get a long URL up in front here. So this is now it actually exposed, forwarded that port and made it available. So this URL is not it's by default it's not you know, public. I have to actually authenticate to access it. That's the default behavior. But if I want to, for example, share this with someone who's not have a GitHub account, I can actually do that by going to a port, and I can actually select port visibility and say that I actually want this to be public. And then you can send that URL to someone, and they can take a look at this as long as you're running your application. And then, of course, you can close it down. So you can see, so that means I can you know, build the application, run the application, run it, debug it, everything like it was on my machine, but it's actually on the machine somewhere in the cloud. And you can use the browser like this, or you can also select to actually open it in VS Code by selecting Open in VS Code. And I mean, the experience is actually very similar, but you know, in some cases it might be nice to, you know, to use your IDE locally. So now it's back in the VS Code. Down here it says actually we're connected to the Codespace. It says down here. And other than that, I can just, you know, continue to run it as normal. And if I take a look in this remote explorer that I showed you in the beginning, you know, I can see my local development things in the containers if I still have them running. These are the ones we created before, or I can also select the Codespaces. So this is now the Codespace that I just created with some information around it. So again, let's go back to this one and say, because now this project doesn't actually have this dev container file, so that meant that when I opened it up in GitHub Codespaces, it just used the default image, which contains a lot of things. It tries to be as wide as possible, but again, typically you would want to kind of customize it for your needs. So again, you would select this add container file. So in this case, it's Node. Let's just pick this one. Okay, not that one. And I get the dev container file, I get the Docker file. We can customize it. Let's add some extensions to it. So I probably want to have like git lens is a nice git tooling. Let's take this one here. Save it. And it actually popped up a little thing down here. It says, hey, I've noticed that you actually changed the configuration file. You want to rebuild the container? Sure. So the same thing that we did locally. But again, this is a little bit different here because now it kind of disconnects, rebuilds the environment, starts it, and reconnects. And everything, all the state you had there, it's still, of course, it's still there. It doesn't go anywhere. That's how, again, how you work with the dev container file. And you see it's exactly the same thing. It's just like it's hosted in GitHub Codespaces. So you get all of these benefits you can use locally today without GitHub or without Codespaces. But Codespace gives you like this environment management to use someone else's machine. So let's see if we come back here. So while wait for that, I'll just mention one more thing around Codespaces. So for like smaller projects, it is very fast, and like the clone time, of course, is fast, and maybe you don't have that much setup. But for larger, like more realistic projects, it sometimes can be that it actually takes a while to kind of get started. It might be a big repository, so just cloning it every time will take some time. And that's extra time compared to what you would have locally, because you already clone it locally, right? And then you might have to do some setup things that take some time. And this is actually a problem that GitHub themselves, they are using Codespaces, and they themselves note this. Of course, they have a large project, which meant that initially it took around 45 minutes to kind of clone it and run the setup things. And that was way too long, because they wanted really to kind of use this as a task-based thing, like just switch task, open a Codespace, and it should be there. So there's I have a link to an interesting blog post where they describe how they went from like 45 minutes to around 10 seconds to open their dev environment for like github.com. And the big thing here was what they call the pre-builds, which is enabled for everyone now. So pre-builds is a way to pre-build a Codespace. As soon as someone commits something, a process will start in the background, which is actually a GitHub action, and it will build that Codespace for that particular commit and branch. And that means that if I'm a developer and I go to say I want to create a Codespace, I can see that it says like pre-build ready. That means that there is already a Codespace for this branch that has been pre-built for you. And when I start that one, it's already built, the code is already cloned, and the setup scripts is already run. So like the getting start experience will be really, really fast. So this is a super interesting way to really make it as efficient as possible. So if you start looking into this, definitely look into pre-build. It's basically just enabling it and say, I want to do this. I think, you want to do this like on a schedule every night maybe, or maybe every time someone pushes a commit or something like that. It's related to how much, the more of these you have, the more you have to pay for them, because they're kind of lying around. But you can configure this to suit your needs. All right, I'm pretty much. This is actually the link to that the blog post that I talked about. So I can recommend you to read it. And it's interesting to read how they actually built this to actually fit their own needs, to move away from the script-based setup that they had, where everybody ran it on their local machine and spent a lot of time, to this one that actually just works for them and for their customers. So that's what I want to talk about, and I'll leave the room for the next speaker. So if you have any questions, you can feel free to just come by here or hook me up afterwards. And so I'll just say thank you and have a great rest of the conference.